My name is Hale, and I'm the chair of the morning session. Welcome. One of the most promising areas in AI, in Gen AI, for me at least, is bringing analysts closer to their data and let them play with the data and try their ideas. And in our next talk, we'll listen to our speaker describe one such system that will use LangChain with LLM to create a data science assistant. And Wissal Jawad is a data scientist at Element Fleet Management. She leverages her master's degree in data analytics to drive business growth through ML and AI solutions. Her area of specialties is natural language processing. Please help me welcome Wissal.
Thank you. The first question I get when someone finds out I'm a data scientist is, how is AI going to affect my job and potentially replace it? So since data scientists are expected to replace jobs with AI, today we're going to learn on how to build a data scientist so we can replace you too. Now, we will be doing this by developing a generative AI solution using the LangChain framework, React agents, and a large language model, which will be broken down into several subtasks, each of which will automatically be performed by our LLM purely by prompting it into the right direction. What are those tasks, you ask? We will cover what are considered some of the day-to-day tasks our data scientists do, like relational database querying, data analysis, hypothesis testing, data science and machine learning modeling, as well as for contextual answers, RAG and SERP API. So for our main components, we'll be using OpenAI as our language model incorporated with React and conversational agents. Phase is our vector database where it will store embeddings to find relevant documents and responses to our questions. LangChain will be our framework in setting up that environment where we will be importing and establishing our tools from. So just an overview, I know there are students, but we will not really be going over specific code. Rather, it's components you can later on use. As an overview of LangChain, the components cover the import of OpenAI, Hugging Face pipeline for text generation, tools for text preprocessing, vector stores such as Phase that we just covered, OpenAI embeddings to generate semantic representation, as well as our agents. So what is an agent? Think of it as an accessory that is used with language models, but they can operate independently. They can reason and choose their own actions to make context-driven decisions. As for reasoning, it relies heavily on the large language model to determine their best course of action. And an agent can be used to search the web, data retrieval, do math, check the weather, and much more. Now that we have that down, we will be utilizing React agents, which is an agent that writes its own prompts automatically. It reasons and acts, hence React. They can interact with tools, enabling them to gather information and perform tasks, which is useful for answering complex questions that would need multiple steps in reasoning, like gathering information from multiple sources to perform several actions to arrive at a conclusion and answer. Math React agents, So database querying, or in this situation, since we are using a LLM, we will call it database natural language querying. Here we will be using the Math React agent, where the LLM connects natural language with complex computations. For this example, we will be using a accounting data frame of employees and their salaries, running the question, what was the maximum salary paid to an employee and to whom it was paid to, and running it through the agent. So since verbose was turned on, we can see the thought process behind the conclusion over here, reasoning on what course of action to implement, the tools that we have previously imported that it decides to use, executing the tool, the result of the execution, and repeating that process until it reaches the final answer, returning the final chain and percent of the maximum salary paid to an employee was $60K, and it was paid to Bob Johnson. So now our data scientist wants to do some data analysis. She'll be using another agent that has a different underlying computation, EDA React agent. For exploratory data analysis, here we can use this to discover patterns, trends, analysis, or modeling. It's interactive and makes the program accessible to a non-technical audience to ask questions and receive real-time insights by automating routine tasks. Its key functions are data cleaning, feature exploration to analyze the different variables in the dataset, visualization, providing summary statistics, and more. To demonstrate its capabilities, this particular agent, we will be using a South African heart disease dataset focusing on patient details and disease risk indicators. Keep in mind that verbose is a parameter that will be set to true so we can see the thought process of the agent, like identifying and selecting the relevant columns for the necessary columns related to the question, execute the calculations, and visualize findings to better illustrate our insights and trends. In the process of execution, we can see the chain of thought, the react process of the LLM, as it reasons through the data, providing a view of its approach. What is the average obesity value, you ask? It reflects, uses the necessary tools, executes, gets an answer, and forms its thought process reasoning to its final answer. Now, as a business user, I have a hypothesis I want my data scientist to explore. So I ask it to perform a t-test with a null and alternative hypothesis. If higher levels of obesity do not increase the risk of heart disease, and an alternative hypothesis of higher levels of obesity increase the risk of heart disease. You can oversee to confirm the process, showing the reasoning behind the final answer of the t-score and the p-value, saying that we reject the null hypothesis and conclude that higher levels of obesity increase the risk of heart disease. Let's say now we want a KDE plot with a labeled axis and for our data scientists to comment on the trend of pattern which the plot shows and comments on the kernel density of obesity among people with and without heart disease. Maybe here you want to see the distribution, or both the KDE and distribution combined. As for machine learning algorithms, we want a binary predictive model that can tell us whether a person has heart disease or not, given all the other columns from our data set. Or like many questions go, given these details about the person, what is the chance that this person suffers from heart disease? How would a data scientist go about this? Well, first we'll give our data scientists options to use random forest, XGBoost, neural networks, SVM, and more, and proceed to clean the data set, pre-process the data for the chosen classification model, implement the model to generate the prediction, and of course we also want the model performance to be evaluated on the data set and explain the rationale behind the model choice. So we run the model. An overview of the verbose quickly tells you I'm not going to be explaining this. So instead, we look at the finale and its final chain, saying it predicts heart disease correctly about 69% of the time. And like a true data scientist, when you have model options to choose from, when in doubt, implement a random forest model. If you have a cool data scientist, you can interrogate them about specialized or random topics. This usually helps with two cases. RAG can answer our questions on given documents that business users don't feel like reading, or Serpapi can answer questions if you're a data scientist is expected to be a know-it-all and regardless of business case. You can use multiple tools when executing the agent. Given a PDF document about process, we ask it, what is a process? It will refer to the document to answer our question and pull out the chunks that it deems necessary. As you can see, the verbose turned on, we can see the different parts it decides to pull in and summarize it to give you the final answer. And lastly, Serpapi, where the answer to the question may not be present in the PDF document. The agent recognizes that and turns to the search tool to search the web and find a possible answer where there is the current, where from there, and asking the question, who is the current president of the United States? You can see it invoking the search and comes back with an answer. Thank you. Please feel free to stay in touch on LinkedIn, and thank you all for coming. Do we go for it? Do I just, yeah? Oh, okay.
Me? Yeah. I guess I have a sort of dual-faceted question. The first being, this is very funny, that it can do sort of the things that I do on the daily. But did you do any measure of actual accuracy of the tasks? Like, it can do the task, but did it give you the right answer?
So yeah, that's why we turned on verbose, so we can see the thought process as it's going through everything. For example, let's say here, when we told it to run the model, you can see the steps it chooses to take. For example, it says here, thought. There are no missing values because we told it to clean the data set, for example, or when it tries to implement and like all the code it decides to run that maybe a data scientist would use. There you can see any gaps or everything like that. You obviously do need a data scientist to overview this. So that's why this talk is called Data Science Assistant. But it is pretty accurate, and we are using the OpenAI model, which is quite well trained.
Yeah, I guess my question is, do you actually have a metric or a measure of the accuracy?
Of like the final result?
Yeah. Mm-hmm. Can you say 90% of the time the final result is true and accurate, or?
Over here? Well, I mean, that's kind of what I'm saying is like the verbose is on, you can see that. And then in terms of accuracy, in terms of like data analysis, you mean, or what exactly?
Yeah, I know there's so many tasks here that it's kind of hard to say. But I guess my question is, if you tried to use this on the daily for normal things that a data scientist would do,
yeah.
On average across the tasks, how often do you get the correct result?
Depending on your language model, I would say, and hallucinations, if you can, kind of go about that. But yeah, I would say it's pretty accurate, but overview, but it is a data science assistant, we would say, call it likewise, but yeah, I would say pretty accurate.
This is really specific, but have you played with the Claude computer use system yet, and some of the robotic process automation that they're attaching with LLMs to do more
I know it's
tasks?
Currently the best alternative to OpenAI. I haven't gotten a chance to implement this model on Claude, but I mean, yeah, it's a pretty tough model, which is, yeah, I've looked into.
I guess my question was different, which is like, this is all running in an IDE, you're generating code, but the new system with Claude is actually allowing it to run applications on your desktop. Mm-hmm. So it's taking the tasks as though the computer were a human user.
Yeah, it's a pretty strong model for sure.
I'm sorry, I also have a follow-up question. How fast is this?
How fast is this? It was pretty fast because you just kind of have the OpenAI large language model put in, but it was pretty quick. I don't know, I just ran it through. I didn't time it.
Yeah, no, it's okay, I was just curious. And then,
depending on the data set, I assume too. I mean, it wasn't a very large data set, but yeah.
The follow-up is, I know that there's a lot of talk at this conference specifically about the environmental impact. So I could do this task, for example, creating the KDE with very little environmental impact. But I think I read somewhere that it tastes like a bottle of water for every query to ChatGPT. So is there any sense of, if I implemented this day to day, how much that would increase like my environmental footprint?
I would say it's actually pretty expensive to try to implement this every day with an OpenAI. You'd have to go heavy on the tokens. Maybe consider using it with a llama model, downloading it on a local if you have a good GPU, or buy a GPU. Any more questions? Okay.
So from what you presented, what would be any improvements that you might make on this if you had the time to make them?
An improvement. I mean, there's definitely a variety of agents that could improve this model, for sure. This is like a base model. Right now I'm just using a couple of agents and advancing it. I believe that a lot of the consulting companies right now are creating something similar and are charging astronomical amount of money. But I mean, adding like agents possibly, but I mean, maybe even if like realistically speaking, if I would want to implement this, looking for a cheaper way to implement this, because it was pretty expensive. But yeah, trying to train it and then refix it and everything like that. So.
Okay, I have a question. Are there specific performance metrics that you would focus on during evaluating such a model, or would you just use the regular ones?
Can you please repeat the last sentence?
I was asking, during evaluating such a model, would you use the same performance metrics, the regular ones, or would you focus on a specific one?
I didn't have a performance metric per se. It was more so of a data science assistant, and that's why we kind of turned on the verbose. That way, yes, you can run your code, like you can do what you want, trying to do faster, but as a data scientist, this is to assist you, and you can look through the code, seeing, okay, no, this is correct, and then you can, confirm if it's accurate or not. Otherwise, you can prompt it to do, like, add something or whatever as well.
Thank you.
Hi, I'm very curious about the degree of babysitting that you have to do.
Can you bring the microphone closer?
Hi, can you hear me?
Yeah.
Okay, sorry. I'm very curious about like the degree of babysitting that you have to do with something like this. I mean, I think we all know that like good prompting leads to good results and so on, and I saw a lot of your prompts were really specific. So like list XGBoost, whatever, choose amongst these. I guess I'm curious, have you tried, instead of step-by-step, do the EDA, do this, do hypothesis testing, throw it a data set and and give it a research question in the way that like a business partner would give it, and have it just run the entire process?
Definitely trying to like make it like having a user interface, kind of packing this all together and advancing it on a larger scale would definitely help that. And then having an underlying mainframe, I would say maybe to help it tell the difference between, like, let's say like a lot of business users aren't going to be like, I have a hypothesis, this is my null hypothesis and this is my alternative hypothesis. That's not realistic, so kind of helping it understand very, very high level business questions and returning that. I would say for now this is a data science assistant, but there's definitely room for improvement to work alone. As a data scientist, I don't know, but yeah. Does it make as many mistakes as a data scientist? I can't tell you that. Any more questions? Okay.
Let's thank our speaker. Thank you so much for all the thoughtful
Thank you.
questions. Thank you.